I'm going to do number 2 on this video, and you guys should be able to do 1 and 3, all right? So number 2, we want to graph this parabola. You always start out by graphing, or by finding the vertex. So everybody write down vertex. Everybody write down the vertex formula. When you use that vertex formula, use parentheses, negative parenthesis over 2 times parenthesis. And then we're plugging in our A value, our B value, and the C value we don't care about. It's not in the formula. But the A value is 1. The B value is negative 6. So working this out, the negative 6 becomes positive 6. And we'll end up with positive 6 divided by 2, which is 3. So the vertex X value is 3. We still need the Y value. How do we do that? We plug in that X value of 3 into the X's of our original equation to find the Y. So my original equation, my original function's Y equals X squared minus 6 times X plus 3. And I put parentheses there because I'm going to be plugging in the 3 in both of those parentheses. So when we do the math, you could use a calculator and type it all in exactly the way it is, or you could just do a piece at a time according to PEMDAS exponents first. 3 squared is 9. Bring down the 6 and might as well multiply it by 3, so you're going to have a minus 18. And then at the very end, you're going to add and subtract. 9 take away 18 is negative 9. Negative 9 plus 3 is negative 6. So the vertex is positive 3, negative 6. Let's graph that. Positive 1, 2, 3. All right, yeah, positive 1, 2, 3, negative 1, 2, 3, 4, 5, 6. That's our vertex. Does this open up or down? Up. All right, great. Now, what's the very next step after finding the vertex? Even before the table, axis symmetry. So let's draw our vertical line right through that vertex. That way, when we make a table, we'll be able to mirror it over to the other side. And not only that, guys, we might as well get used to practicing writing the equation of this axis of symmetry. Remember, any vertical line, it's not going to be a y equals mx plus b line. It's going to be an x equals. Any vertical line is not going to be a y equals. It's going to be an x equals. So what is this axis of symmetry equation, this green line right here? It's going to be x equals, and it's simply the x value that this green line is at. What x value is this green line at? It's at 3. That's really just, if you don't know it already, it's the x value of your vertex. Right? The axis of symmetry is the x value of your vertex because your vertex has this x value, so the line has to go through that x value. So the equation is x equals 3. All right, what else? They wanted us to state the domain and range. The domain is going to be x what? Equals all real numbers, okay? And the range is y, and it's going to be either greater than or equal to or less than or equal to, depending on whether it's opening up or down. So it's opening up, so it's going to be greater than or equal to. And what is that y value of the vertex? It's negative 6. So we've stated the domain, the range. We need more points, so let's go to an XY table because they're asking us to go to an XY table. Which 2 numbers would be good to plug in?
2.
1 and 2? 1 and 2 are great. Now, it would not be good to plug in, let's say, negative 2, because here's 0. Negative 2 for x would be way over here, and that's clearly really far away from this axis of symmetry. You want to pick 2 values that are close to the axis of symmetry and on the same side of the axis of symmetry. So if you say 1 and 2, yeah, that's great. So you want to plug in 2, you want to plug in 1. If you plug in 2, it's going to give you a coordinate somewhere over here. Plug in 1, it's going to give you a coordinate somewhere up here. If you plug in 0, it's going to give you a coordinate somewhere up here. I don't know. So you can plug in 3, plug in 2. Let's do a couple. Let's plug in 2. And let's do this together in our heads, even though I don't recommend it. Use a calculator when you're taking a quiz or test. So 2 squared is what? 6 times 2 is what? 4 take away 12. What's 4 take away 12? Negative 8. What's negative 8 plus 3? Negative 5. Thank you very much. So our coordinate, our input 2 gave us the output negative 5. Let's go to the coordinate 2 on the x, negative 5 on the y. We will be right here. Which other coordinate should I plug in? We said 1, right? Let's do the math here. 1 squared? 1. 6 times 1? 1 take away 6? Negative 5. Negative 5 plus 3? Negative 2. So the coordinate 1, negative 2 is the next coordinate. 1, negative 2, it's right here. And I could mirror those points over to the other side of the axis of symmetry. And we will have our perfect parabola. That's a regular shaped parabola. It just looks a little wide because we didn't extend it further, right? Now, how about this? The only other thing I could ask for, like so far we have the domain and the range, that's great. We have the vertex, that's great. We have the axis of symmetry, that's great. Even though the instructions don't ask for all those things, they just want you to graph it. We also could ask you to state the y-intercept. The y-intercept. What is the y-intercept? Now, if you're looking for it visually, you don't know exactly if it crosses here or up here or maybe up here. How could you figure out the y-intercept algebraically? Yeah, you set x equal to 0 and solve it. And it becomes a really easy problem. Finding the y-intercept is the easiest problem because it's always going to be your c value. Because when you set x here and x here equal to 0, everything becomes 0 except for your c value. And you can even write it as a coordinate over here. When you plug in 0, what do you get out? A 3. So 0, 3, 1, 2, 3, it's up here on the edge. That's your y-intercept. So the y-intercept, set x, that would give you the coordinate 0, 3. So the y-intercepts are really easy to do. You set x equal to 0, and that's how we get the 0 on the coordinate for x. And it's always going to be your c value. And that's everything you could possibly state about a parabola. So what do? We graphed it. Of course, we stated the vertex. We made an xy table. We found the domain and range. We stated the y-intercept being 0, 3. We know that the axis of symmetry equation is x equals 3. And that's about it. The only other option that you could have done when graphing is recognizing that the a value is 1, which means you could use a pattern 1 over 1 up, 2 over 4 up, 3 over 9 up. So you could have gotten even another coordinate to make it go further. And then it doesn't look that wide anymore, right? But you don't have to use all the way to you don't have to go all the way to the edge. Anyway, I hope you guys could do now 1 and 2. Now, the middle portion, 4, 5, and 6, it says, find the vertex, the equation of the axis of symmetry, and the y-intercept. So they want you to find all these details without actually graphing it. So let's go for number 6. How could I find the vertex there? Use the formula. That's right. Use the formula. X equals negative b over 2 times a. It's going to be negative parenthesis over 2 times parenthesis. The a value is 4. The b value is negative 4. The c value is 1. So the b value is negative 4. The a value is 4. When we simplify, we get positive 4 over 8. So we have 4 over 8. That reduces down to what? Don't say 2. Yes, that's right. 1/2. So the vertex x value is 1/2. I know a lot of people are freaking out right now. Oh, I have to plug in a fraction. So what? Deal with it. Let's see. Let's plug in the 1/2. It's going to be 4 times 1/2 minus 4 times 1/2 plus 1. If you want, you could type all of this exactly the way it is into the Casio calculator, and it'll give you the y value. Or if you want to actually go with it and do the math on paper, that's also good. 1/2 squared, 1/2 times 1/2 is 1/4. And when you multiply the 1/4 times the original 4 that was out there, it cancels out. You end up with a nice, beautiful 1. When you multiply 4 times 1/2, that's really going to end up with a negative 2. 4 times half is 2. Half of 4 is 2. Bring down the plus 1. You really have just adding and subtracting. 1 take away 2 is negative 1. And then negative 1 plus 1 is 0. So the vertex y value is 0. So the vertex is 1/2 comma 0. They asked for the vertex. We found the vertex. You could check your answer on the back. Go ahead, check it. Is the vertex 1/2 comma 0 on number 6? Yes? Great. And instead of 1/2, they use 0.5, right? That's fine. You could use decimals or fractions. Now, in addition to that, In addition to that, they are asking for the axis of symmetry equation and the y-intercept. Okay, so remember, if I were to graph the coordinate, the axis of symmetry would be the vertical line right through the vertex, right? But they want the equation of the axis of symmetry. The equation of a vertical line is not going to be y equals, it's going to be x equals, and it's going to be the x-axis, or the x value of your vertex. So what's the equation of this axis of symmetry without even seeing it on a graph? X equals 1/2. Okay, you're going to have to do this on Friday's quiz. All right, you're going to have to state the axis of symmetry equation. And if you don't put x equals 1/2, you're not going to get it right. You have to remember that the vertical line has to say x equals 1/2, which is simply the x value of your vertex. All right, they're also asking for the y-intercept. Are they asking for the y-intercept? Yeah, for the y-intercept. And how do you find the y-intercept? Well, you set x equal to 0, which means that it's simply your c value. Because if you plug in a 0 right here for x and right here for x, what do you end up with? 1. The c value is 1. So what's the y-intercept? 0, 1. Easy peasy lemon squeezy. So you guys should be able to do 4 and 5. Let's take a look at 7, 8, and 9. It says, consider each equation, determine whether the function has a maximum or minimum. How do you determine if a parabola has a maximum or minimum? Just by looking at the a value. Number 8, does it open up or down? It opens down. Does that mean you have a max or a min? Max. Right? If it opens down, it's going to reach a high point and then it's going to come back down. It reaches a maximum, right? So because it opens down, it has a maximum value. If we keep reading the instructions, it says find that maximum or minimum value. So if they're telling you to find the actual location of the maximum, what are they really asking you for? The vertex. Remember, the vertex is the most important point. It's the highest or lowest point. So if they ask you to find that maximum location, they're really asking you to find the vertex. So let's find the vertex. Vertex. It's a coordinate. Coordinates found by using x equals negative b over 2 times a. Negative parenthesis over 2 times parenthesis. The b value is 5. The a value is negative 1. The c value we don't care about on the formula. There's a 5 right there, and negative 1 right there. We end up with x equals negative 5 over negative 2, which is 5/2, which we could also call 2.5, right? I don't know. So the vertex x value is 2.5, and we need a y value, okay? So how do we find the y value once we already have the x? Plug it in. So you have y equals negative x squared plus 5 times x minus 10. All you have to do is put in the 2.5 right there, 2.5 right there, and do it on a calculator. So on a calculator, we get negative 15/4 when we type it in exactly the way it is, and you can switch to a decimal, it's negative 3.75. So our y value is negative 3.75, so the vertex is 2.5, negative 3.75. Whoop, that's ugly. 0.75. So that's our vertex. That's what they're asking for. We know it's a maximum value. We found the maximum value. We also need to state the domain and range. The domain is going to be what? X equals all real numbers. And I don't know why, but in the back, they just write out the words all real numbers. And they don't even put x equals all real numbers. They just write all real numbers. I would like you to write it the way I write it, right? The D, the colon, x equals that funky looking R. The range, they also write it different. The range is either going to be above or below a certain value, and that's the y value of your vertex. So does this parabola open up or down? Down. So our graph is going to be below, which means our y values are going to be less than or equal to the y value of the vertex, which happens to be negative 3.75. And that's the range. And if you look at the back on the answer sheet, they don't write it with this notation. They use this other different notation. Just write it like this on your answer sheet on the test, and we'll be good. And that's about it. That's all they're asking for on this section. Maximum, minimum, state the domain and the range. That's it. And the final section is actually graphing, right? Actually graphing. So If I wanted to graph 12, you got to go through all the steps. Should I go through this, or you guys already got this?
Isn't it the same as 1?
I mean, yeah, they're pretty much all the same. You just always go through the same steps. Step 1 is to find the vertex, which is a coordinate. And you get that by doing x equals negative b over 2 times a. And the b value is 8, the a value is 2, the c value is 1. We don't care about that one. You end up with the 8 value of b in there, the 2 value of a right there. We end up with the negative 8 divided by 4, which is negative 2. We have negative 2 for x. Let's find y. You're going to end up with 2 parentheses squared plus 8 parentheses plus 1. We're plugging in the negative 2. We're doing the math. Negative 2 squared is 4. 2 times 4 is 8. Bring down the minus 16. 8 times negative 2 is negative 16. Bring down the plus 1. So we really have negative 8. When I go 8 plus negative 16, that's negative 8. Plus 1 is negative 7. So the vertex y value is negative 7. When you graph negative 2, negative 7, you'll end up down here. We do that in red the way I usually do. Next thing to do is to graph your axis of symmetry. Might as well state the axis of symmetry. The axis of symmetry is x equals negative 2. That's the axis of symmetry. We need more points. We're going to go to an XY table to find more points. And when I go to an XY table, which values would be good to plug in? You want to plug in 2 numbers that are on the same side of the axis of symmetry. Negative 1 and 0 is great. Okay, so let's do negative 1, and let's do this together in our heads here. Negative 1 squared is positive 1, right? What's 2 times 1? 2. So we have 2 right here. 8 times negative 1 is negative 8. 2 plus negative 8? Negative 6. What's negative 6 plus 1?
7.
Negative 5. Let's graph the coordinate negative 1, negative 5. There it is. Let's also plug in 0. When you plug in 0, that'll automatically give you the y-intercept anyway. When you plug in 0, that'll be your c value as your answer, your output, which is 1. And if we go to 0, 1, we end up here. Ladies and gentlemen, those are all the points that we need to get a perfect graph. All we have to do is map them over to the other side. 1 right here, 1 over here. Connect the dots, you're good. Let's state the domain. X equals all real numbers. State the range. Y is, what is it, greater than or equal to or less than or equal to?
Greater than.
Greater than or equal to, because the parabola opens up. So it's above the y value of your vertex. So what's the y value of your vertex?
9, negative 9.
Negative 7.
Yeah.
It's up here, guys. The y value of the vertex is negative 7. Here's your vertex. The whole parabola is above it. I hope this helps. Finish it up.